Hey, Cyprien here. In this video, we'll talk about how to analyze a very simple model, and I will use this opportunity to teach you about the analyst mode. So this will really be basic video, the most basic you can find um, about how to write your own analyst script and how to go with a simple OnScale model. And let's talk first a bit about the simulation process. So the simulation process has three main steps. First is the pre-process of your model. The second is solver, and the third one is the post-processing. So in general, the pre-processing is where you build your model. So you associate the loads, the boundary condition, etc. The solver is where the software calculates the model, and the post-processor is where you review your results and check what you actually want to calculate. So this will look like that. Well, first, you'll make your model, then those data are sent to the solver, and those data, your model data, are generally written under a script format called an input deck. So that's what I will show you how to write. Then it goes to the solver, which calculates that, and it generates all the types of data in different formats. And then you can review those results either in the post-processing or using different ways. So the simulation process in OnScale can be slightly different because there is a new component in it, which is the cloud. So basically, everything you send to the solver is uploaded in the cloud because OnScale solvers are in the cloud. So, and there are two parts, designer and analyst. So designer is where you generate your model into the GUI graphically. Then when you generate this model, some script code is generated, which is actually analyst mode code. And this code is called an FLX input deck. And this is what is sent directly to the solver. So the main benefit of doing like that is that this script is very, very small. Whereas a designer file contains geometry, a lot of information, so models can be huge. So Analyst Script is just a few lines of text, so this file is very small and easy and fast to upload on the cloud. So there are other benefits that I'll also talk about later. And then you have to download the results. So once it's calculated on the cloud, you can download your results. So you have different types of results, either time history curves, which are stored into FLX HST, like history, and field data, which are stored into FLX data file. So should you use GUI or Analyst Script? Well, if you are new to OnScale, I would advise to use the designer mode to generate the model because it's all graphical and it's pretty easy to use and to generate the model. And then you have the analyst mode. So analyst mode is basically the script version of what you built into the designer mode. So in some exceptions or advanced model, you'll need to build an analyst script because there are some high-end functions that are not yet available in the GUI. And how is a model actually composed? So it's very, very useful to understand the building blocks of the model in OnScale. And actually, it's pretty similar to any other FEA software. So the model is composed of geometry, is composed of loadings, which are applied to this geometry, some boundary conditions, and some material data. And all kind of other parameters, variables, and things you want to set up, etc. And then you have a discretization of this model into a mesh. So in OnScale, the mesh is a grid. So this is the standard grid approach. So the good points about that is that it's mainly automatic. No need to really, refine the grid on some specific parts. Well, in some cases you need to, but I mean, um, it's not exactly working like in the other software. And generally, it's pretty automatic. We have also other kind of meshes in OnScale, like Tetra Mesh, etc., is also available in the Analyst mode only for the moment. But the main type of mesh which is used now is Hexa Grid Element. And generally, the way it is structured into an analyst file is the following. First, you have your mesh, which contains like points, nodes, elements, all that. And this is generated using mainly two commands, the grid and the geom commands. Then you have your material and the geometry. So material properties are associated to mat command, like material. And the site command is here to assign the material to your geometry. And then you have boundary condition and loadings. So here you have three kind of commands that are often used. Func is to create a function instead of time, in function of the time, I mean. BO and boundary is here to assign the boundary conditions. Plod and piece are two different load types. So this is for a pressure type of loading, for example, and this is for piezoelectric type of loads. And then you have all other type of commands which are related to the execution of the solver and the outputs you want. So POUT is to export time history data. Data is to save what you calculated into a file. PRCS is to basically check your model before it goes to the solver, and exec is the main command to execute the model. So you can see it like that. First, the analyst mode is, and the model is built using these various functions, which have to be defined in a certain order into the script. So you can do that using the GUI, of course. You don't have to write it. But for the purpose of this training, this simple training will work mainly on the scripting part too. So you understand how this is structured. And then you get an analysis script which is composed of those different parts. So generally it starts with building the geometry, the material, the meshing, the loads, boundary condition, the analysis, and the output. So if you remember this kind of analysis process, you see that mainly you'll understand how the analyst scripts are written. And there are also a lot of useful comments which are written directly into the script. So if you don't know what this is doing, you can read those comments in green, or you can just right click and there is a way to check in the documentation what the comment does. So in this very simple series of videos, I'll show you how to write a simple 40 lines analyst mode script of sound wave propagation. So we'll look together how to create a grid for that and how to generate a simple model using this kind of script. So you can start now with the first video.